You see the green square is there, and here is the transfer of data. So that's there, but then when I go here, hey, it's live. They fixed it. Well, hello YouTube. I am back. My name is Nick, and in this video we are going to set up two more. This is going to be the odd video, right? Actually, no. Let's do it. Hello and welcome back to Calculus 3. We are going to set up two more integrals for the triple integration. Oh no, but this is going under the wrong title. Okay, so forget what I said. Let's just set this up, and then I might change the title later. So this is the oddball video. It's going to be short. Here's a cool one. 20. The wedge is bounded by the parabolic cylinder y equals x squared, and the planes z equals 3 minus y and z equals 0. All right, so what do we have as a result of this? So we have our x-axis, we have our y-axis, and we have our z-axis. Now, it has a parabola y equal x squared, so that has to be a parabola on the floor. And then we need to draw the line parallel to x to kind of cut it off. Now I need to just erase this extra stuff over here. All right, so now that I have this, this parabola is going to go to a certain height and then connect into these and connect there. There we go. So this is a wedge, right, which is rounded to the parabola, as you can see. There's the sharp corner here going to the y direction. And we just need to set up the integral to compute the volume. If you get any kind of distribution function, you can plug it in and calculate the bulk. So we start with figuring out the outer integral. But remember what I did first the last time. I said, as you are setting up these rectangular integrals or the general regional integrals, this could be some fx, y, z, right? That's up to the problem to add that later. We're going to do the z dy dx. We'll try to put the z dy dx every time because it's easy to think that way. When you have the z dy dx, the most inner integral is z, and the z is the top surface and the bottom surface. Now they are explicitly given those to you, right? So you see that the bottom surface that bounds the object is z equals 0. That goes on the bottom. And the top is 3 minus y. So there's your bottom and the top of the 3D shape as you're setting these things up. Then you have your y equal stuff over here. Y equal x squared, and you want to draw a representative rectangle. Now, what I do is I say, okay, this is going to be now the domain, and we know that in the domain, this is the y-axis, this is the x-axis, I have a parabola that is cut off, because that cut off, that edge on the top, is this edge over here, right? That's that. So now I know that the equation for this line is y equals x squared, but I don't know the height for this y. And I need that because when I draw my representative dx rectangle, I need the information for this top line, because the top line intersected with the parabola will give me A and B. And I need those, A and B, over here. And I need this straight line for the top. And I know this one on the bottom is x squared. So this rectangle moves from A to B. I need to find those, but in order to find those, I have to have the straight line on top. Also, the equation of straight line goes on the top of the middle integral, right? So I need to figure out the way to figure out what is the equation for the top line. And it's going to be y equals a number. Y equals 2, y equals 3, y equals 4, whatever it is. How do you propose to find that line?
Find with
Square root of 3y. Nice. So this line, this sharp edge, is on the floor. The floor has a value of z equals 0, and we have an equation that connects y and z, 3 minus y. So y is 3. Right? So this value over here is 3, which makes this value over here to be 3, because on the plane, right, z equals 0, and when I plug in z equals 0, I get that y is equal to 3. And that's the one that goes around. So that's 3. So great. I know that now this is 3, and this is x squared. And as you suggested, a and b are negative square root of 3 and positive square root of 3. Very good. Yes?
like on a test, you were saying something yesterday about a lot of times the question is just going to be about setting it up and not actually integrating?
Yeah, because you should be, software is going to integrate for you.
Yeah.
I am primarily interested in if you're able to set these things up. As a mechanical engineer, civil engineer, electrical engineer, your job is to come up with these integrals, and then machines are going to take, machines can't do this yet. When they can, will be relevant as a species. But yeah, we're going there. Slowly but surely. Or no, fast, actually. But for right now, you still have some security in job and relevance, knowing that you can at least set up these integrals. Machines are now, at this point in time, not able to set it up, but they can compute these things much faster than you. So, yeah, there's that. Let's set up one more problem and then move on to the next portion of our life. Well, this looks insane, but that's just because we are using the wrong coordinates. So, guys, problem... you can't see because I haven't logged in. Problem 23 is an absolutely diabolical problem for the section we're in. But as soon as we cover the cylindrical coordinates, it becomes a joke. Okay? So that's something that is interesting. So I'm not going to spend time setting up something that we will never compute. Let's actually take a look at something that we could be having fun with. How about, ooh, okay. This is nice, 22. So, good luck drawing this thing now. All right, so now we have our x, y, z perspective this way. We are going to draw a parallel line here, parallel line here, go straight up, have the curve over here,
How do you know like which style to draw?
I'm just copying from the textbook right now. I'm not coming up with any of my stuff, but you try. And the way I learned is I actually rotated 3D shapes in the software because I used to play a lot with AutoCAD because it was interesting to me. So for my 3D perception, just by playing video games, the entire life playing 3D video games for like 20 years, that really helps a lot with perceiving these things, because every video game looks 3D, but it's 2D, right? Your screen is 2D. So they're managing to fool you into the 3D perspective. And now even with VR, it's even better, right? Move
your head in the game.
Yeah, I know. If I go to the Rift for like a few hours, then when I take it off, it hurts.
Yeah.
Like the head starts hurting, so just put it back on. It's fine.
You have one?
Yeah.
That's cool. I want one.
Rift? It's now $400. It used to be $600. Rift. Oculus Rift is now $400. Used to be very expensive. Now it's like, I mean, there's still not too much content for it.
I just like the racing.
All right, there we go. Perfect. So this is our shape. Yes.
What are the dotted lines when we meet in solid lines?
Those are just to give us dimensions.
Okay.
So to get the 1 and ln2 and all this kind of stuff.
Is that representing the shadow of the shape, though?
The shadow of the shape would be this rectangle over here. So it's, I don't know. So those of you that are trying to make sense out of this, see the rectangle over here. Yes, ln2. This rectangle over here that it's looks like a parallelogram is actually the bottom of the shape. So yay, what do we have as our domain looking at this shape, right? You have your XY coordinate system, and it's all in the first quadrant, ln2 by 1. That's what you have. Or you can't have easier region than that. So as we are setting this thing up, I mean, look at it. You have, okay, maybe you have X, Y, Z here, maybe you don't. That's up to the problem, the rest of the problem. We are going dz, dy, dx. Outer x is 0 and 1, right? Because a representative rectangle stretches from 0 to 1. And then the top of the representative rectangle is always hitting ln2. The bottom is always hitting y equals 0, which is x-axis. And now all I need to do is figure out, now they give you in the text that the top surface is e to the y, and the bottom surface is 1. They give you two functions over here. So this surface over here, they say z equals e to the y, and then surface on the bottom, so they're taking, tell you this is 1, so that's z equals 1. It's a plane parallel to the floor. And there you go. So now you will be integrating the inner one, and then the middle one, and then the outer one, and you are done. So 3 Calculus 1 integrations. And you plug in, calculate the limits. And that concludes that. So we're going to switch to cylindrical and spherical coordinates and do that. So, okay, it's stream.